Okay, hello guys, how are you doing? Today we are going to see surface analysis. Uh, this is very important and a spatial analysis in a GIS environment. This includes analysis of slope, aspect, view shed, terrain, equation, elevation, agroecological zone. Before any analysis, we have to identify our area of interest. Uh, If it is watershed, you have to delineate watershed. If it is some administrative boundary like Kabale district and Warada or zone or region or at country level, you have to identify that. And then the next requirement is you have to have the digital elevation model dataset. Yeah, you can download it from the trustworthy source. For this lab, already we have downloaded and we do have the dataset in our system. So go to your JS software and open it. Here we do have this uh, digital elevation model of our region. And now you can analyze all this origin or the elevation, slope, and other surface analysis like terrain, view shed, and other surface analysis or in the contour like that. And also you can select your own area of interest, right? Uh, so you can select, for example, let's select this one, this zone. Let's select this zone. I've selected purposefully because it will generate agroecological zone based on Ethiopian context, and then you can create layer from selection, and then you can export this and save in your output folder. Here in output folder, this zone, the name of the zone. To know the name of the zone, you can label the name. This is Bali, yeah, Bali zone. For origin, this is Bali zone. Bali zone, okay. Yes, and remove this one, the temporary one, and clear selection, and now again remove this zone and make it this one hollow, and all right. And now let's extract by mask our area of interest. Yeah, all right. Okay, extract by mask. And then our input is aromatium. And our mask feature is the Bali zone, and here let us save our DEM Bali digital elevation model, and okay. Takes time. Be patient. Wait. yeah. I guess it is done. And now you can remove this, and make it full extent your area of interest. Here we do have this area of interest, right? The Valley zone. Okay. One thing you have to keep in your mind is that before any spatial analysis, you have to be sure that you make active the spatial analysis. You see here spatial analyst toolbar, this one, right? This one, spatial analyst toolbar. For example, if you run this, it creates a histogram of the DEM. See here, it creates the histogram of this digital division model. And again, you have to also be sure that you make active the spatial analyst extension. This one, spatial analyst extension, already it is done. Therefore, before any spatial analysis, you have to make active the spatial analyst extension as well as the spatial analyst toolbar. Right. Now everything is okay. And again, before any analysis, you have to check your data, whether it is projected or not, right? Whether it is it has reference system, coordinate reference system or not, right? Without a coordinate reference system, it is difficult or it is impossible to analyze spatial analysis. So if it is not defined, you have to define the correct coordinate system. And if it is defined and not projected, you have to project the data. So let us move to here. You see, here we go to source, and you can see all the information about your data, raster data here, or vector data, or spatial data. So look here, raster information, columns and row. You see here this one. Number of bonds, it is single bond. Yes, DEM is a single bond. Cell size, you see this is the cell size. By the way, simply by looking at the cell size, you can understand whether the data is projected or not. It is not projected. You see, it is in decimal number. It is what do you call it? In this digit, right? So this tells us the data is not projected. And the format, you see, the uncompromised type, the format, and the source type, pixel type, right? And then the other information that tells us about whether the data is projected or not. This one, spatial reference. The XA coordinate system is geographic coordinate system. You see, it is geographic coordinate system. The unit of measurement is angular, degree, minute, and second. So in order to analyze our data in spatial context, we have to project our data. That enables us to calculate linear measurement like length, area, percentage, and on, right, which is very important information. So the datum, here we do have this data, right? And here we do have other statistics, okay? So now we have understood that this data is not projected. So the next step is we have to project our data. So open this Archetype box and go to what? Data management tool, and you can go to projection, and then you can go to raster projection, and project raster tool. So you can project it. As you know, Archetype box has a lot of tools, spatial tools, so it takes time to open. So we have to be patient, right? And it also depends on our PC performance. All right, it is opening, right? Yeah, go to here, it opens. Go to data management and projection and transformation and raster progression. Open this one and your input raster is valid DEM and it is already, it has a coordinate system and geographic coordinate system. Now we are going to convert this to projected coordinate system and here save it. DEM what valid, okay, and then okay, I think is it linked or similar. Authorizer data set, authorizer data set and the value already exists. Yes, that one is there. So we can say this one from projected, right? See, then value proj underscore proj projected, and here select the correct coordinate system, projected coordinate system by default in my favorite. Here I do have this. If you don't have this one, you have to go to where? This one, projected coordinate system. Already we do have this geographic coordinate system. This is in angular measurement. So go to this projected coordinate system and select the right coordinate system, right? Okay, here now, the resampling technique should be the nearest the default. Let us accept the default. Here we do have the cell size. Cell size should be by default to this one, 92.5 by 92.5. And here you can also have the chance to uh, uh, to modify the cell size, right? But for the time being, let us use the default one. Okay. Yes. Here we do have the projected one. So let us remove the unprojected. And then now you can go to property and you can check. You see here, no, cell size is not in the like that of the previous one. Now it is like this, right? So now it is projected, and again you can check here the linear measurement in meter, right? That means you can calculate area in hectare, kilometer square, meter square, and okay. All right. And the next step, now already we have make our data ready to analyze spatially. Okay. And the next step is let us generate elevation. Go to property and here go to symbology and they classify this into 5 classes. In Ethiopia, we do have 5 agroecological zone regions based on elevation. So in order to generate this 5 agroecological zones, we should have these 5 classes, and here you can select the color ramp as you like as you want. And then here, you see, here we do have this is the ranges of elevation or altitudes of this valley zone. Okay, this valley zone. Okay, see valley zone. And this is the red one is the highest point. Okay, especially the highest point up to the 4,385 meter above mean sea level. That means this is Bali Mountain, part of the Bali Mountain, which is the highest peak in Oromia region and even in Ethiopia. It is one of the highest, among the highest peaks in Ethiopia as well. Okay, so now you can calculate the area and you can generate the agroecological zones of this region. Okay, how can we do that? For example, if you open this attribute table, it is in this one. We can't calculate for each cell, right? You see here, it is difficult to do this, right? So the solution is we have to what? Reclassify this by 5 agroecological zones by this range, right? So we can use the reclassification tool, which is very important in spatial analysis. Reclassify. Classify spatial analysis. See, classify and add this by this, see, by this range. Already we do have 5 classes, and here we do have new value. Here we do have all the value, the 5 classes of the altitude range of Bali zone, and here we do have the new value. So now the output will give you the new value. So you have to be careful and keep in mind that you have to have this information, all the value. You have to have the record of this all the value, and next you will add a field in your attribute table of this new value, and then you can add this all the ranges of all the value, and then you will calculate the area, and then you will also give the respective agroecological zone name of each altitudinal range. Okay, if you further wanted to know the method, basically we do use the default method, but here we do have bunches of methods you can use based on your objective and your interest, right? So for the typing, let's use this one, the natural break method. Okay, and then if you need to reverse the value here, you can reverse, right? If you delete entry, you can delete entry, and you can add entry if you have entry in your system. And here is the output raster. Here the output raster. Here again, the what we call it, elevation. Valley, mountain. Oh, sorry, valleys, valleys, or this issue of what lengths. Ellip, we can say ellip. That is elevation. Okay, and then see here all the value and the new value. You have to have the record of this. One new value, 1 represents the range of altitude from this up to this, and 2 represent from this up to this, right? So it will be easy for you to insert the range and to calculate to compute other analysis. Okay. Yes. It gives us this one. Why it gives us this one? I think we have selected one. Wrongly, you have selected one row or record. That is why it gives us, okay, well, we have to be careful. We have selected, right? We have selected one thing, one row, in the table. I remember that we have selected ellip underscore balance. Okay, this is the second one. Okay, here you do have that. All right. I think again, look, again, go to here and go to here. See, I think here there is one row selected. we can clear the selection. Hmm. 5 classes, okay. You see, now it is okay. Prevision is because we selected it, right? Careful, be careful. It is technical thing. You select a row, the system gives you only the selected one. That is why it gives us. It was giving us the first, only the first class. So this is the class, right? Now we can open this one, the attribute table of the reclassified one. You see here we do have the value 1 up to 5 and the count, the cell number of cells, or that gives us the total area, right? So here you can add on the field, and you can say here range of elevation, or you can say altitude range, and it should be double altitude range. Sorry, the range, it should be guide, right? You are gonna to insert range, and then the other one, add the other, okay, range, agroecological zone, agroecological zone. This should be what? Text. In Ethiopia, we do have how many agroecological zones? 5. Berha, Kolla, Wenadega, Dega, and the Wurch. So agroecological should be written in text. You have to be careful when insert the domain. And the next one, area. You can calculate area now. It should be in double. And again, calculate the percentage coverage of percentage coverage, or simply you can say percentage, and there should be double domain. And now here you have all this empty, okay. Okay, here in between you have this empty, what here you have this empty fields, because we're going to calculate the area and insert the agroecological zone based on the range and the percentage. Okay, that agroecological zone should be based on the parameter of agricultural zone grouping or characterization of Ethiopia. Okay, the next one is let us first insert the range. Okay, insert the range. Got table of content. Here we do have from 300 to up to 1022 meter range, the first one, and from 1002 up to, here it is, I'm reading this one, up to 1494, and the second one from 1494 up to 2111, and from 2111 to 2950, and the last one from 2950 to 4,385 meter above sea level. Okay, now open your attribute table of your agricultural zone and make editor active. Very important. This one tool, by the way, editor is very important. I like it in ArcGIS environment. All right, here insert the range. Okay, now from 3 to what? 1000. Okay, 22. And here from 1000 to what? 1494, and the second one from 1494 up to 2111. This one from 2111 up to 2950, and the last one from 2950 meter upper mean sea level to 4385 meter upper mean sea level. Okay, here this agroecological zone, the first one. Okay, in order to insert this agroecological zone, you have to use the already parameter in Ethiopia. For example, agroecological zone of Ethiopia. The first one is Baraha below 5, you see, below 500 meter, right? So here in our range, we do have below 500 meter. It is Baraha, and this is the climate and agricultural practice. And the second is the Kolla lowland between the first one below 500 and Kolla below what? Below 150. Wenatega between 150 to 1,500 to 2,300, and this is Wenatega from 1,500 to 2,300, and Dega from what? 2,300 up to 3,200, and Wurch above 3,200. Based on this is the geographical agroecological zone of Ethiopia. So the first one, you see this one from 300 to meter upper mean sea level up to 1,000. We can so classify it as Baraha. Okay, next one is the Kolla. Kolla is below what? 1,500, right? Yes, almost it is below 1,500, or it is between 1,022 up to 1,494. Yes, exactly. It is the exact zone in this area. And the second one, the next to Kolat is Wenatega. Wenatega, we have said that from 1,500 up to 2,300, almost is approximately, it is correct. It is correct. And the next one is the Dega between 2,300 up to 3,200. Yes, almost approximately it is about that. And this one above 3,200. Yes, this is what? The Dega. Basically here you can say this one, you can say this one less than. This less than what? Less than 500. You can say less than 500 to be logical, right? And this one, you can say this one is greater than. This one is greater than 3,200 millimeter. No, exactly. Sorry here, less than. This one should be less than than, and this one should be greater than. Okay, greater than this. Okay, and the next step is we have to calculate area. Here you can calculate area. Fill the calculator. Area is equal to count. You see, count multiplied by what? Multiplied by an area of a single cell. How can we access this area of a single cell? Go to table of content. Okay. Go to, oh, sorry. Go to table of content and go to here and go to this layer property and go to this one is the cell, an area of a cell. Okay, copy it. And then again, go to here, open this attribute table and go to area. Now, fill the calculator. This one is multiplied by what? Count multiplied by its area of a cell. This again is the area of a cell is this one multiplied by this one. And now, if you are going to calculate the area or compute the area in hectare, you have to divide this by 10,000. And if you are going to calculate the area by kilometer square, because it is our area is very large, it is zone, right? Instead of calculating the area by hectare, we have to calculate it by kilometer square. So you have to divide by 1 million. 1, 2, 3, 4, 5, 6 zeros, right? 1 million. Okay, now, okay, it is in kilometer square. We calculated our area in kilometer square. You see, even it is large number, even in the kilometer square, each zone is large because our area, study area or area of interest is very large. It is a zone. Okay, so now calculate percentage here. Calculate percentage. To calculate percentage, you have to have the total statistics or total area. Go to statistics and this, copy this total area and go to here and fill the calculator. So percentage is equal to area, okay? Area multiplied by what? 100. And divided by what? The total. So, you know this concept? If the total is 100, what will be the area of each zone? The total area of the zones is how many percent? 100%. So we can calculate in such a way to get the percentage coverage of each zone. Okay, now make it okay. You see here, this is the percentage coverage of each zone. This one is the largest zone. That means Kolla. Kolla is the largest in Bali. Right? The next one is the Barha. And the next one is the Wena Dega. And which are, sorry, this one is which, guys? Which are very small, have small coverage respectively. Okay, now let's save our editing. Save it and stop it. Stop it. We have finished, right? Such a way we can analyze, right? And now let us back to the, here you have already the what? New values. Now already we have done a lot of analysis and we can map our map based on okay, agroecological zone, for example, right? You see, this is based on agroecological zone, and Wurch. I call that the blue one. This is Kolla. Okay, and then you can go to this view and then to the and make it full extent here and insert all other map element, the legend, title, northern row, scale, blah blah blah. right? And then you can export here, and can export it, and then you can integrate in your document and analyze it. This is how to generate agroecological zone, especially using reclassification tool, right? And how to calculate or compute area and percentage of this agroecological zones. And it works for all other elements, especially a slope class. You can calculate the area of different slope class based on the slope classification. You can classify your slope, and then you can calculate area and then percent of area. And it works for all land use land cover classes, right? You can calculate the different land use land cover classes, area coverage and percentage and the like, right? Okay, this is all about how to analyze surface analysis, especially how to generate elevation and agroecological zone in particular area. Thank you for watching. Next time we'll see how to generate other surface analysis uh, activities like slope, and view shade and on, right? Thank you for watching.